algebra students, Mr. Lawrence here, and I'm getting frustrated because it's about the third time I've tried to make the video and the computer keeps acting up, but you don't need to hear my troubles, you just need to hear the video. So let's get on with it. Real quick, before we get the actual lesson, I'm gonna do two problems from the homework. They're not actually from the homework, but the same type of problems. The first one is to find the perimeter of this rectangle. I know that the top side is 6x plus 4, and the height is 3x minus 5, and I also know that because it's a rectangle, that this side has the same measurements. Oops, I didn't mean to do that. Control G, there we go. And all right, I feel powerful. And this one here, Control D. All right, so a problem like this is super simple. I'm surprised so many of you are having trouble with it. Look, perimeter is just the distance around the shape, around the polygon. And all we're going to do is combine like terms. So I'm going to count my x's. And it looks like all together I have 18 x's. Dun, 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 dun. All right, now I'll count my constants. I've got a positive 4 and a minus 5. Well, that's a negative 1. And a positive 4 and a minus 5. That's another negative 1. So I have a negative 2. And then it's in centimeters. Bam, I'm done. What's hard about that? We're just combining like terms. Count your x's, count your constants. Now, problem number 2 is a distribution situation. I have a negative here, a negative 1, so I have to distribute my negative to all three terms in the second quantity, which means I'm just going to multiply them all by negative 1. Now, the directions on the homework might say something to the effect of do it the horizontal or the vertical method. Well, that's fine. All it means is, do you want to write it like this? Or do you want to write it like this? I don't care which way you do it. If it says horizontal and you do it vertically, I'm really not going to get upset over that. I'll do it the way we've been doing it traditionally, which would be to do 5x squared minus 2x plus 6. And then after I distribute my negative 1, I get a negative 3x squared minus a 2x and a positive 8, right? So here we go. How many x squareds do I have? Well, I have 5 right there. And I have a negative 3. And plain old x's right there. And then my constants. There we go. All right, so now I'm ready to combine like terms. 5x squared minus 3x squared, 2x squared, not 2. I'm counting x squareds. I have 5 of them and I lost 3 of them. I have 2 left. If I had $5 and I lost $2, I wouldn't have 3 left. I'd have $3 left. If I had 5 dogs and I lost 3 of them, I wouldn't have 2 left. I would have 2 dogs left. All right, the x terms, I've got negative 2 and negative 2 is a minus 4x. And the constants gets me a plus 14. And there you go. By the way, this answer would be a quadratic trinomial. And the answer above would be a linear binomial. And there you go, piece of cake. All right, let's get on to the real lesson. What we're going to do is we're going to find the nth term. We're actually going to write an equation for this nth term. But before we do that, I want to talk to you a minute. Do you remember being back in like 6th grade or 7th grade or 5th grade or something? And they gave you a series of numbers and they said, write the next 3 numbers in the sequence. And I don't know about you, but I see questions like that and I get insulted because they're so simple. They're not even challenging. Now, maybe like in lower elementary school, you thought, oh, this is cool. I'm so smart. I got it right. But now you're algebra students. You're in high school math class. This kind of stuff is a waste of your time. It's too simple. But what wouldn't be a waste of your time would be to ask you for a way to figure out, say, the 500th term without listing the first 499th. Okay? Well, what we're going to do, and I'm going to go off on a tangent here, is we're looking for the nth term. The nth term. N is just some unknown number. Okay? We're going to count all the way up, 1, 2, 3, all the way up to n. And then we can keep counting, of course. Now, n is just an unknown number. It could be the 50th number, could be the 75th, could be the 101st, could this be the 68,000th, 68,322nd number. Could be a lot of different things. So let's see here. First of all, let's see if you know what number comes after n. And if you're thinking O, please drop and give me 5 push-ups right now. It's not O. Okay. Now, if you're having trouble with this, let's play a little game. You ready, Maddie? Maddie and I are going to play a little game. Maddie, I'm going to name a number. You name the number that comes after it in counting, and I'm going to ask you how you got there. You ready, Maddie? Okay, your number is 7. Name the number that comes after 7 in counting, Maddie. Of course, it's 8. Now, how did you get there? What's that? Did you say you added 1? Very good. 7 plus 1 is 8, right? I should move that plus 1 over a little bit if it'll let me. Nope, it's making me move the whole thing. All right, so 7 plus 1 is 8. All right, Kayla, you ready, Kayla? Your number is 37. What number comes next? Well, 38, right, Kayla? Very good. How did you get there? What's that? Added 1. You got to speak up. It's hard to hear you. Got Miles Davis playing in my ears right now. Okay, one more. This one is for Mr. Griffo. Mr. Griffo, your number is 3,627. Let's not use a 7. Let's make it 21. Okay, Mr. Griffo, what number comes next? 3,622. How did you get there? That's right, Danny, you add 1. So, what number comes after n? What's that? Zach knows. N plus 1. Of course, I add 1 more than the previous number. Then the next number would be n plus 2, and so on. Now, what number would come before n? Let me think here. Who's going to know this? I'll bet Sam knows this. It'll be n take away 1, or n minus 1. And the number before that, I'll bet you Sarah can tell me. N minus 2. Good. So we're looking for the nth term. If we can find a formula for the nth term, we'll be able to figure out any number term we want without listing them all out. And the first thing we're going to do is we're going to make an input-output table. I just so happen to have one right here. I was keeping it in my sock for just such an occasion. It's an input-output table. All right. And all I'm going to do is I'm going to take these numbers, and the first one is 6, right? So 6 goes under the 1. The first term is 6. The second term is 8. The third term is 10. Fourth term is 12. And the fifth term is 14. And I'm going to go looking for the first differences. If the first differences match, I'm going to do the yippee skippy dance because this will be a good thing. The first difference here, how do I turn 6 into 8? Well, I have to add 2. 8 to 10, I add 2. 10 to 12, I add 2. 12 to 14, I add 2. All right, so I'm adding 2 every time, right? When the first difference matches, that is going to be my coefficient on n. So my answer will be something for the nth term will be something like 2 times n. Now notice I didn't write it up here because what I'm going to do is I'm going to make this thing called a comparison line. And I'm going to take the n numbers, 1, 2, 3, 4, and 5, and I'm going to put them into this expression, 2 times them. So this one here is 2 times 1, which of course is 2. 2 times 2 is 4. See that, Jose? I'm just taking these numbers right here and multiplying them by 2. Why am I multiplying by 2? Because the first difference was plus 2 every time. All right, 2 times 3 is 6. 2 times 4 is 8, and then 10. Now I do my comparison. I ask myself, how do I turn 2 into 6? Well, I add 4. 4 into 8, I add 4. 6 to 10, I add 4. 8 to 12, you guessed it, I add 4. 10 to 14, I add 4. Well, what do I do for my nth term? Well, I take 2n and I add 4 to it. Okay, now my equation is going to be f of x, which will equal 2 times x plus 4. To figure out the 301st term, I'm going to put 301 in for x. And so 2 times 301 will be 602, plus 4 will get me 606 for my answer. 606. There you go. Piece of cake. And I didn't have to list the first 300 terms. I don't know about you, when I do this, I feel so smart. Okay, here I have another sequence of numbers. Again, I make my input-output table, and I'm going to fill in the numbers. The first number is 5. Second number is 9, 13, 17, 21. I go looking for my first differences. That's plus 4. That's plus 4. That's plus 4. That's plus 4. The first difference is always plus 4. It's a linear pattern, and it'll be 4 times n. Now I do my comparison line. I take these x numbers, 1, 2, 3, and I plug them in for n. So 4 times 1 is 4. 4 times 2, 4 times 3, 4 times 4, and 4 times 5. And I ask myself, how do I turn the comparison line into the actual answers? It looks to me like for each of the blue ones, I have to add 1 to get one of the red ones. It's always plus 1. Which means my nth term is 4n plus 1. My equation will be f of x equals 4x plus 1. To find the 301st one, I'd put 301 in here. It'll equal 4 times 301, and I will add 1 to whatever I get. Well, I believe that'll be, oops, 1,204 plus 1, which will be 1,205. And there you go. Piece of cake. Okay, one last one, and then we're going to wrap this video up. All right, here we go. Again, I make my input-output table, filling in 5, 1, -3, -7, -11, and I find my first differences. Ooh, it's -4. Ooh, it's -4. It's -4. It's -4. That means my nth term is going to be something like -4n. Draw my comparison line. Plug in 1, 2, 3, 4, and 5, and I'll get -4, -8, -12, -16, -20. And then I'll say, how do I turn -4 into +5? I think I had 9. -8 plus 9 is 1. Looks like I'm adding 9 every single time. Okay, well, if I add 9 every single time, my formula must be -4n plus 9. My equation will be f of x, and that will equal -4n plus 9. Oh, -4x, excuse me. So f of 301 equals -4 times 301 plus 9. That'll be a -1,204 plus 9, which should get me a -1,195, I think, right? And there's your 301st term, -1,195. All right, there you go. It's that simple. Mr. Lawrence signing off. Good night, everybody.